Okay, this is part 3 of our review on systems and matrices. So, given these matrices right here, if I want to do negative 3b, that just means take matrix B and multiply everything by negative 3. So that means that I would have a negative 6 and 0 and negative 3 and positive 12. Alright, that is a 0. Alright, so this just means multiply each element by negative 3. Now, if I want to do A minus B, so I'm doing this minus this. In order to subtract, they have to have the same dimensions. And we've got that. This is 2 by 2. This is also 2 by 2. So we just need to subtract each corresponding element. So if I want to do A minus B, then it's going to be another 2 by 2 matrix. So it's just 6 minus 2, negative 4 minus 0, negative 2 minus 1 is negative 3, and 3 minus negative 4 is 7. Let me just emphasize that. 3 minus negative 4. Please understand that when I subtract this minus this, I wind up doing this minus and negative business, and that of course is addition. So I wind up doing 3 plus 4, that's why I'm getting 7. Okay, so that would be my answer number 2. Number 3, I'm supposed to do D minus B. Is that bothering anybody besides me? Why is that bothering you? Yeah, you cannot add or subtract matrices that do not have the same dimensions. This is a 2 by 2, this is a 3 by 2. You cannot add or subtract these. So this is undefined. Okay, or I guess you could say not possible. Number 4, C squared. Please be careful. When we had our quiz last time, so many kids just wanted to square this and get 4, 9, 16, 4. That's wrong. Okay, you do not just square the entries. C squared means multiply matrix C by itself. Okay, so I need to take this 2, 3, 4, negative 2, and I need to multiply it by itself. 2, 3, 4, negative 2. And again, still, when you multiply two matrices, you do not just multiply corresponding entries. That would be the same thing as just squaring all of these. Instead, when you multiply matrices, you have to do rows and columns. So look, this is a 2 by 2 matrix, and this is a 2 by 2 matrix. So I know that my solution, the product, is going to be another 2 by 2 matrix. So in other words, I'm going to have an element 1, 1, element 1, 2, element 2, 1, and element 2, 2. This is row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So if I want to find each of these elements, for example, say if I want to find element 1, 1. Let me zoom in a little bit. Okay, if I want to find element 1, 1, I have to do row 1 times column 1. That's row 1 from the first matrix, okay, 2, 3, times column 1 of the second matrix. So that's 2, 4. Alright, so I need to multiply row 1 times column 1. So that's going to give me 4 and 12, which is 16. Okay, so that tells me that element 1, 1 is 16. Booyah, Jim. So that'll be 16. Now I'm going to find element 1, 2. Why not? Okay, so if I want to find element 1, 2, that means I need row 1 times column 2. Row 1 is 2, whoops, no division line. Okay, row 1 is 2, 3. column 2 is 3, negative 2. Okay, so I'm doing row 1 times column 2. If I multiply that out, I'm going to get 6, and I'm going to get negative 6. Add them up, I get 0. What? So that means element 1, 2 is 0. Okay, kabam. Let's move on to element 2, 1. Time for green. Okay, so element 2, 1. That's row 2, column 1. Row 2 is 4, negative 2. Okay, column 1 is 2, 4. Okay, that's going to give me 8. I'm multiplying, and negative 8. That is another 0. So element 2, 1 is once again 0. Okay, and finally I need element 2, 2. Oh, that's row 2, column 2. Row 2 is my 4, negative 2. Okay, column 2 is my 3, negative 2. So I'm doing row 2 times column 2. So that's going to give me 12 and positive 4, which is 16. A lot of repetition here. So this is going to be 16. Alright, so this would be c squared. Okay, right here. Alright, I feel like I should highlight it to emphasize that this is the answer. Okay, let's move on. Okay, look at number 5. We need to find dA, that's d times a. The order matters. So make sure we do d on the left and a on the right. So dA, so this is matrix D, and this is matrix A. Okay, so now we're ready to do d times a. Now, before we get too carried away, let's make sure that it's even possible by analyzing these dimensions. All right, so this is a 3 by 2 matrix, and this is a 2 by 2 matrix. For this to be even possible, the inner dimensions have to be the same. They are, so it is possible. Now the outer dimensions tell me the shape of the product, my answer. So my answer is going to be a 3 by 2 matrix, similar to D. Okay, so that is helpful because I'm going to set that up. So my answer is going to be in the shape of a 3 by 2 matrix. So I'm looking for this. Element 1, 1, element 1, 2. Element 2, 1, element 2, 2, element 3, 1, element 3, 2. Okay? Setting up the shape helps you make sure you're not missing anything. It's got to be a 3 by 2 matrix, 3 rows, 2 columns. So now I just have to find each of these 6 elements very carefully. Okay. I'm going to zoom in, mostly so I can write very small. Okay, almost microscopic. So I am going to go ahead and begin to do this. So element 1, 1. I'll also be way over here. So element 1, 1. that means row 1, column 1. So that's row 1 is 3, 1. Column 1 is 6, negative 2. Okay, that's going to give me 18 and negative 2, which is 16. All right, so that's element 1, 1. Okay, let's move on. So now I'm going to do element 1, 2. That's row 1, column 2. So row 1, so again that's 3, 1, but column 2. Okay, that's negative 4, 3. Alright, so that's negative 12 and 3. So that's negative 9. Alright, so element 1, 2 is negative 9. Okay, let's go ahead and do element 2, 1. Alright, element 2, 1 is row 2, column 1. So row 2 is 2, 4. Column 1, 6, negative 2. So that's going to be 12 and negative 8. So that's going to be 4. Alright, so element 2, 1 is 4. Alright, element 2, 2. Alright, this takes kind of a long time. What are you going to do? Okay, element 2, 2. That's row 2, column 2. So that's going to be 2, 4 and negative 4, 3. Okay, so that's going to be negative 8 and 12, which is going to be positive 4. So that's element 2, 2 is positive 4. Okay, 2 more to go. Let's do element 3, 1. Running out of colors, man. Alright, so let's do element 3, 1. That's row 3, column 1. Row 3 is 0, 1. And column 1 is 6, negative 2. Alright, so that's 0 and negative 2, so that is negative 2. So element 3, 1 is negative 2. Okay, how about element 3, 2? Okay, that's row 3, column 2. So row 3, that's 0, 1. Column 2, that's negative 4, 3. So that is 0 and 3, which is 3. Alright, so that's element 3, 2. Alright, that is it. That is how you find the product of D times A. Alright, now for number 6, we're supposed to find the determinant of the following matrix. Okay, this matrix right here. Of course, the determinant is when we just do the down diagonal minus the up diagonal. So let's say, imagine that this is matrix A. Then the determinant of this matrix would be the down diagonal, which is 4 times 7, minus the up diagonal. Okay, so that's why we're just going to have 28 minus, be careful, okay, in fact usually I kind of do this, down diagonal minus up diagonal. So that's 28 minus negative 14, all right? Watch for the minus negative. So of course that means we're going to wind up doing addition. So that means that this determinant of what we're now calling matrix A will be 28 plus 14, which of course is 42. Okay, so the determinant of this matrix is 42. All right, what's next? Find the inverse of the following matrix. Now the inverse, this is where we get to reverse negate. But first we have to find the determinant, all right? That's sort of step one. So first we find the determinant. Again, I'm going to call this matrix A. Okay, if this is matrix A, then the determinant of A, as we just discussed, is going to be the down diagonal minus the up diagonal. Okay, so that means down diagonal minus up diagonal. So that's going to be 20 minus negative 24. All right, again, minus and negative. So please, please be careful. So this is going to be 20 plus 24. So that's going to be 44. Okay, so that's my determinant. I'm going to save this for later. All right, because when I do the inverse, all right, which I call A inverse with a little minus 1, I'm going to have to lead off with the reciprocal of this. Okay, so I'm going to put 1 over 44. This really means I'm going to wind up dividing everything by 44 at the end. But that comes later. Okay, now what goes in here is the reverse negate. Now when I say reverse negate, I'm talking about the down diagonal and the up diagonal. We need to reverse the down diagonal. Okay, if I reverse these, this will become 4 and 5. Okay, so I reverse those. I need to negate the up diagonal. Now that doesn't mean everything is going to be negative. It means everything's going to change to the opposite of what it is. So this negative 3 is going to become positive 3. This positive 8 is going to become a negative 8. Alright, so there's your reverse and negate. Now, like I said, with this 44, that means I need to divide everything by 44. So just for a minute there, I'm going to have this. Alright, A inverse. And just for a minute, I'm going to have 4 divided by 44. And negative 8 over 44. And 3 over 44. And 5 over 44. Okay, now this is the inverse, but we need to reduce these fractions for the final answer. Okay, so A inverse is going to equal, all right, the same thing. I'm just going to reduce these fractions. So 4 over 44 is 1 over 11. Okay, and this is going to be negative 2 over 11. 3 over 44, that does not reduce, nor does 5 over 44. Okay, so this is the answer. Alright, I'm just going to put a little box around it. It's kind of hard to see, isn't it? Alright, maybe that wasn't the smartest move. I'll just leave it white. Okay, that's the answer. So that was number 7. That means there must be a number 8 over here somewhere. Okay, so same thing. We need to find the inverse of this. But the first step of finding that inverse is the determinant. So I need to do the determinant. We'll call this A. So the determinant of A is going to be, once again, the down diagonal minus the up diagonal. Okay, so down diagonal minus up diagonal. So that's going to be negative 24 minus negative 24. Interesting. Of course, minus and negative is addition, so that means the determinant of matrix A is going to be negative 24 plus 24. Uh-oh. That means that the determinant of A is 0. Huh. What does that mean in terms of finding the inverse? Well, right away, that tells me that there will be no inverse. Okay, so that means A inverse is undefined. Okay, there is no inverse when the determinant is 0. Think about it. Look at what we did last time. Once we got that inverse, the first thing we did with it was we did 1 over. Once we got the determinant, first thing we did was 1 over the determinant, 1 over 44. Now here we have 0. If we follow the normal procedure, the first thing we do is we do 1 over 0, and then here we'd reverse and negate. But you cannot divide by 0, right? 1 divided by 0, that's undefined, which is why the inverse is undefined. Okay? Alright, so no inverse whenever the determinant is 0. Let's go back to number 9. Use the determinant to find the area of the triangle with vertices, boom. Okay, so we're given the vertices and we're supposed to find the area of this triangle. Now, the way we learn to do that is we're going to set up a 3x3 matrix. Alright, if you recall, and the matrix looked like this. See this point, negative 4, negative 3, here it is. Negative 4, negative 3. See the next point, 0, negative 4. And see the last point, 3, 1. Okay? For the third column, what do? That's right, I use a bunch of 1s. So 1, 1, 1. Okay? So I've got this 3x3 matrix. Notice I'm using straight lines here instead of the usual squares because straight lines mean determinant. So I'm about to do the determinant of this 3x3 matrix. Now, just to complete the formula, and you really should do this every step of the way, and you only do this when you're finding the area of a triangle using matrices. But for the area of a triangle, part of the formula is we put a plus or minus 1/2 here. So we'll find the determinant, but then we'll take half of it. And then the plus or minus just means choose whichever sign you need to make your answer be positive. But your final answer must be positive. You can't have a negative area. So how do we do the determinant? Well, we recopy these columns. So I'm going to recopy and have there's my negative 4, my 0, my 3. I'm recopying. I'm going to recopy this column as well. So negative 3, negative 4, and 1. Then I'm going to do down diagonal minus up diagonal. Only there's 3 of them. So there's a down diagonal, another down diagonal, and another down diagonal. Okay, so I am doing, so I still have my plus or minus 1/2. Don't forget about that. But I'm doing my down diagonals minus my up diagonals. Okay, that's positive 16. So that's one of my down diagonals. Negative 3 times 3 is negative 9. Okay, times 1 doesn't change anything. So that's my next one. Anything times 0 is 0. So that's my third down diagonal. Now it's time to go back and do my up diagonals. Okay, my up diagonals are here, here, and here. Okay, 3 times negative 4 is negative 12. And then times 1. 1 times 1 is 1, times negative 4 is negative 4. And again, anything times 0 is 0. Okay, all I have to do is evaluate this, and I'm done. So plus or minus 1/2. Okay, guys, let's see. 16 minus 9, I'm just going to put all of this in my calculator, alright? Obviously I could do this step by step, but a lot of you guys make mistakes when you do that. And so I just want to be clear that there's no reason for you to ever get these problems wrong, because you can use your calculator. So I'm just typing in this part. So, okay, 16 minus 9. Alright, okay, I am leaving out the 0. Minus negative 12 minus 4. So negative 12, negative 12 minus 4. And again, I'm leaving off the 0. Okay, that comes out to be 23. Okay, so that's a big old 23 in there, alright, because that's the part I did. Now we still have to do the 1/2. Since it's positive, then I just make sure I keep it positive. So half of 23, alright, so this area, you could either put 23 over 2, or you can go ahead and give me a decimal, so which I believe is 11.5. Right, see, 23 divided by 2, 11.5. Alright, and that is how we find the area using vertices. Okay, now, don't go thinking that every time we do the determinant or every time we find an inverse, it's always going to be 1/2. This plus or minus 1/2 business, this is only for finding the area of a triangle. Alright, now that bell rang and I have a meeting, so hopefully I'll be able to come back and finish this video later, un poco más tarde. Okay, last one, number 10, word problem. Please do this problem on the back of your paper. There's no space, obviously. This is going to take some space. Let's write this system. A group of students go out for lunch. If 2 have hamburgers and 5 have hot dogs, the bill will be $8. Okay, so we will use H to represent the price of a hamburger. And we will use D to represent the price of a hot dog. Alright, obviously I'm using D for dog. Okay, so hamburger and a dog. So let's see, what do we have here? Okay, 2 have hamburgers, so that's 2H. 5 have hot dogs, so that's plus 5 dogs. Hamburgers and dogs. The bill was $8 in that case. Okay, now if 5 have hamburgers, so that's 5 have hamburgers, and 2 have hot dogs. So 2 have dogs. The bill will be $9.50. So it's $9.50. Alright, what is the price of a hamburger? And let's find the price of a hot dog while we're at it. And we're supposed to use matrices. So this time we're going to convert this to a matrix situation. by doing this. This is going to become matrix 2, 5, 5, 2. All right, that's my coefficient matrix. And then, of course, the variable matrix, HD. Okay, and that's going to equal the constant matrix, 8 and 9.5. All right, this is our matrix equation. And let's label this. You must label this. So this is matrix A, this is matrix X, and this is matrix B. All right, that is mandatory. Do not skip that. And in fact, I need to see this as well. So that means so far we have A times X is equal to B. All right, which means that X will equal A inverse times B. Everything I have here in red must be on your paper. If you leave this out, you're losing points. So please do not throw away 6 points or more just because you did not write down this red stuff. You have to label and put this theory, the matrix equations down. And then you can go ahead and do it. Now, if you understand that we have to do A inverse times B, then you understand that we need to first find A inverse. Okay, so let's do that. All right, so over here off to the side, let's go ahead and find A inverse. Okay, if I want to find A inverse, first I need the determinant of A. Okay, so the determinant of A, of course, that is down diagonal minus up diagonal. So the determinant is going to be 4 minus 10. 10. Whew, that was awful. 4 minus 25, that was a little scary. Okay, that means the determinant of A is going to be negative 21. So that is the determinant. So at the end of the problem, I'm going to wind up dividing everything by negative 21. Now, that means when I go to do the inverse, okay, my A inverse is going to be 1 over negative 21. And here's where I reverse and negate. Reverse, negate. Okay, so this is going to be, so when I say reverse, I'm talking about the down diagonal. Okay, so, okay, reversing these doesn't really do anything. So that'll still be 2 and 2. And then I'm going to negate these, so they will become negative 5 and negative 5. Okay, so this is the inverse. Go ahead and leave the fraction out front. Do not divide everything by negative 21 until the end of the problem. Okay, so this is my A inverse. Now, we have to do A inverse times B. So that means, okay, A inverse, so we're doing this. Let's see, what colors will I use? I think I'll use brown. Okay, so X is equal to, now I need A inverse and I need B. Okay, A inverse is this stuff right here. So it's my 1 over negative 21. Okay, and the 2, the negative 5, the negative 5, and the 2. All of that is A inverse. And then that's supposed to be times B. Okay, well, B is right here. It's 8 and 9.5. Okay, so I have to multiply this out. To get X, which is this matrix, I have to do A inverse times B. Now, the easiest way to multiply A inverse times B is to first multiply the matrices and then, at the end, divide everything by negative 21. So that's what I'm going to do. So please understand that what I am looking at here is a 2 by 2 matrix and a 2 by 1 matrix. Therefore, the shape of my answer will be 2 by 1. So that is useful to know, my people. Whoa, that's not what I meant to do. All right, that means my answer is going to be in the form, it's going to be a 2 by 1. So that means I'll have element 1, 1 and element 2, 1. All right, all I have to do is find those elements and I'm done. All right, because that top one will be the price of a hamburger and the bottom one will be the price of a hot dog. So here we go. I think I'm going to switch back to red. So let's go ahead and find element 1, 1. Okay, that was a terrible 1, 1. Let me try that again. Let's go ahead and find element 1, 1. Much better. 1, 1 means row 1 times column 1. So row 1 is the 2 and the negative 5. Okay, that's row 1. The column 1 is our 8 and 9.5. So 8 and 9.5. All right, 2 times 8, that is 16. Okay, and 5 times 9.5. Okay, it's 5 times 9.5. Let's see, you can't quite see that. Oh, it's right here. Haha. That is 47.5. In fact, I could put this way off the screen. Whoa, too far, too far. Okay, I just let that hang out over there. Yeah, 47.5. So negative 47.5. Add those up. Okay, so 16 minus 47.5. So that's negative 31.5. Okay, that is element 1, 1. Wait, I lied a minute ago. Not on purpose, silly. I lied when I said once we found these elements, those would be the answers. Because I'm like, negative $31.50. A, that doesn't make any sense because you can't have a negative price. And B, even if it was positive, that would be way too expensive for a hamburger. But I was forgetting for a moment about the dividing by negative 21 part. Okay, so please, 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 that is still there. 1 over negative 21. So it will not be the final answer until after I divide everything by negative 21. Anyway, so far I have found element 1, 1. Okay, so I'm going to go ahead and put that in. So I found that that is negative 31.5. Okay, now let's find element 2, 1. All right, which I will do in pink, my friends. Okay, so element 2, 1. That's row 2, column 1. So that's negative 5, 2. Okay, that's row 2. And column 1. So that's 8, 9.5. Okay, so row 2, column 1. So that's negative 40 and 19. Right? Because 2 times 9.5 is 19. Okay, now I'm supposed to do negative 40 plus 19. Okay, so that's why we have negative 21. Okay, so that is element 2, 1, which goes right there. Okay, now for the final answer, we have to divide everything by negative 21. So I have to do 31.5 divided by 21. So 31.5, okay, divided by 21. That is 1.5. Okay, so that tells me, okay, so that is 1.5. That means the cost of a hamburger is $1.50. That makes more sense. And of course, negative 21 divided by negative 21 is simply 1, which tells me that the cost of a dog or a hot dog is $1. Okay, so we should wrap this whole thing up with a sentence. So hamburgers cost $1.50 and hot dogs cost $1 each. All right? Okay, and because of course, because of these numbers right here, it turned out that H was equal to 1.5 and D was equal to 1. All right, that was the last problem. I hope this video has been helpful to you, at least a little bit, and I will see you on the next video.